right? So thank you for coming this event. So here, my name is Jin Young Park. I'm the moderator of this event. So the title of this event is 2023 BrainLink X Lab Day Talk Concert. And especially the title itself is Optimism, Pessimism, and the Realism of Large Language Models. So here, there are 9 speakers in here. And then, and then especially, so the president of the COA FST comes to here. So please welcome to the president of Tae-Sik Lee.
Distinguished fellow scientists and engineers, welcome all of you to the 2023 BrainLink X Lab Day talk concert on optimism, pessimism, and realism of large language models. I will call the BrainLink X Lab Day talk is a BXL, like the BTS. Do you know the Korean pop singers? I appreciate the organizers, Professor Jin Young Park from Sungkyunkwan University and Professor Eun-Sol Choi from the University of Texas for successfully orchestrating today's X Lab Day. Thank you so much for all of the speakers, panelists, and chairs for their contributions. I call the Korean Federation of Science and Technology Societies. F is silent, so COST, you can call that COST, has 608 members organization from industry, academia, and research with 13 regional federation and 19 overseas Korean Scientists and Engineers Association. This extensive network lays the foundation for the development of the BrainLink X Lab Day, I call BXL, as Korea's largest private science and technology organization. We are committed to leading networks for international cooperation in science and technology. The BXL was started last year with a view to establishing research network at the global level while fostering technology exchanges among eminent scholars, seniors, and early career scientists and engineers from home and abroad. In 2022, the first project hosted a total of 14 technology exchanges meetings with 449 participants actively engaging in the event. This laid the foundation for successfully networking among scientists and engineers. The BXL will host 10 technology exchange meetings in Gangwon Province, Korea, covering 12 national strategic technologies. I believe you already invited for the international member of the COST because we will make that right now million members, but we will extend the international members. You are welcome to be joining in the COST. No fee. Furthermore, we have arranged a special talk concert like today with the speakers of the BXL project, aiming to extend the knowledge sharing platform beyond the in-depth exchanges reserved for a select group of experts. As you know, you had a closed meeting, but that is your very intimate talk and discussion. But today is very open. We will use the YouTube channel, so you will get maybe 100,000 people, hopefully. But your area is a very important, very impressive area. I hope the BXL will create a virtuous cycle structure that will eventually lead to a host of new global research opportunities in numerous technology fields. You may know the Korea 2024, our R&D budget will be $25 billion, but 10% we will collaborate the international network. So this BXL is a very important open area for all of you. ChatGPT, with the emerged last year, has brought significant changes to our daily lives and triggered a paradigm shift in the AI industry. This AI proficient in understanding and generating natural language, the language of humans, is more than just a tool. It is an architect ushering in a new era of natural language processing. Large language models are driving innovation across diverse areas, from enhancing business such capabilities to contributing to international development. I'm sure that this BXL become a valuable platform for exploring the multiple aspects of large language models and providing deep insights into the field through dynamic and robust exchange of ideas. I hope that all of you find this event to be valuable networking opportunities. I appreciate your participation in this meeting. I wish you all the best in the future endeavors. Thank you so much. Welcome to Korea.
Yeah, thank you to the president to explain and welcoming the speakers and the audience. So and then sorry forgot that. So actually the president introduced this event well, but I want to play the video for this event. Let's see. Let's watch the video.
Amidst the world's rapidly accelerating changes and competition, what kind of future are you preparing for? We are chartering a path to the future through science and technology exchanges, bolstered by international cooperation. In this era, where scientific and technological competitiveness is directly linked to a nation's diplomacy and security, the power to overcome such challenges lies in international cooperation that fosters synergy through collective efforts, and from talents who will shape the forthcoming era. The scholars of the world are gathering in Korea. A platform that facilitates exchanges between Korean and international scholars, as well as between seasoned and emerging researchers, is taking shape. BrainLink X Lab Day, organized by the Korean Federation of Science and Technology Societies, aims to be a global hub of talent. By consistently enhancing and expanding the global talent network, we're laying the groundwork for a brighter future. By inviting global scholars, X Lab Day provides an opportunity for young Korean researchers to glean insights from the vast knowledge and experience of both Korean and international scholars, as well as to engage in collaborative research. In 2022, the inaugural X Lab Day saw a total of 14 meetings across various technical fields. Altogether, 449 individuals participated, comprising 70 from overseas and 379 from Korea, all aiming to build a stronger network in Korea and abroad. This year, for our 2023 X Lab Day, we have the honor of having Xingteng Yao, professor at Tsinghua University and a Fields Medal winner, Philip Kim, a globally renowned professor at Harvard University, known for his research in graphene, Yoon Sung Hwang, professor at Stanford University and Hoam Award winner, and Humboldt Research Award winner, Zhigang Suo, professor at Harvard University, leading discourses of their respected fields. This year, the discussions will span 12 national strategic technology fields pivotal to Korea's advancement, including quantum mechanics, nuclear technology, and AI. The event will see the participation of 30 Korean and international scientists and engineers. With 2 organizers leading each technical segment, the gathering will foster in-depth academic exchanges, encompassing the sharing of recent trends and information in core technology fields, in-depth discussions on research findings, and the sharing of ideas. The focus of XLab Day is connectivity and sustainability. Following the event, communities and clubs will be established based on each XLab Day session to ensure ongoing dialogue among attendees and promote collaborative research. To ensure that today's dialogue becomes the seed for tomorrow's magnificent achievements in scientific and technological development, COAST supports the reinforcement and expansion of the networks established through XLab Day. COAST, the organizer of XLab Day, stands as a beacon for Korea's science and technology society. Established in 1966, its mission has been to safeguard and amplify the rights and interests of scientists and engineers. Our endeavors extend to enhancing the public's grasp of science and technology and furthering its development through comprehensive policy research, planning, surveys, and consultations. As Korea's largest science and technology network with over 600 affiliated organizations, we are committed to promoting domestic and international cooperation and exchange. In the transformative era of the 4th Industrial Revolution, where science and technology spearhead groundbreaking challenges, COAST remains dedicated to its role as a facilitator of scientific and technological innovations. In this era of technological dominance, we will navigate through the fierce competition by fostering global cooperation in the fields of science and technology. BrainLink XLab Day aims to broaden both domestic and international talent networks and become a global hub of talent. By making XLab Day into an event that scientists and engineers worldwide eagerly join, we intend to elevate Korea's global standing and bolster national competitiveness. Global Talent Hub, BrainLink XLab Day.
Yeah, thank you so much. And then the next, the program is the speaking. So speakers will come to the stage and then they give a short presentation which is about their large language models and their own research. So the orders is like that. So from Youngjin Kim, Jason Wei, Hyunwoo Kim, Chin Yurin, and Alan Ritter, Hae-ju Jang, Keisuke Sakaguchi, and Wei Su, and then last speaker is Ling Peng Kong. So yeah, please come to the stage, maybe here or over there. I guess that's the place, yeah, for the presentation. Yeah, please welcome to the speaker.
Hello everyone. Thank you for having me here, and it's an honor to be here. Today I'm going to talk about briefly about multilinguality in large language models, about what's in there and how to better utilize. As many of us know, I borrowed this from Jason's paper. So large language models show very interesting emergent behaviors. So as we increase the compute model size or the data size at training time, the models start to show some abilities not observed in the lower compute, low flops region suddenly, and these kind of behaviors are very unpredictable, and it appears suddenly in many cases. So my focus of research is about multilinguality, and so we wondered how about like multilingual capability, especially the machine translation capability, can appear in this kind of emergent behaviors. Even though large language models are trained on huge amount of data, still they are very English-centric. On the right-hand side, on the black table, this is the data composition of GPT-3 training data set. And the white part at the very right side is the distribution of tokens on different languages for training PaLM model. And as you can see here, for GPT-3, 93.68% is all English. The second most frequent language is German, but it's just 1.19%. And all the other languages are less than that. And also PaLM trained more on the multilingual data, but still English is 77.98%. The second most frequent one is German, still only 3.5%. So we wondered, even with this very small portion of the training data, thanks to the emergent behavior and reasoning capability of large language models, we wonder if LLMs or GPT can still have the machine translation capability. Especially when we look at the data a little bit on the left-hand side, we saw that some parallel data, which means source from English or to German, there are some data, very small amount of data exists in the training corpus. So interestingly, when GPT-4 was announced, the OpenAI also announced a blog post about machine translation, especially the Icelandic is very kind of low resource language, but from GPT-3 or 3.5 to GPT-4, they show very impressive performance improvement on the machine translation task. So we did some evaluation of the large language model GPTs on machine translation task with various settings. So we started with zero-shot performance, and then we utilized the in-context running by showing some example sentences, translation sentences. As you can see here, we observed that the GPT systems can achieve or outperform the state-of-the-art, the best system, translation systems. Here, red bars and blue bars are the existing translation specific systems, but with few-shot learning, the stars are the scores of the GPT models. They could outperform the existing state-of-the-art systems. We see this happens consistently in many different language pairs. The previous slide, I showed one of the most frequent language, which is German, but we saw the similar pattern on the German, Czech, Japanese, or Chinese. Here, but we still see some low resource languages, which is very few data points. We see still GPT models struggles in that region. After looking at these GPT's amazing capabilities on translation, we looked at some smaller large language models. We call it SLLM, because the GPTs are good but still expensive. We looked at more efficient models, model sizes ranging 7 billion or 13 billion parameters. And we saw the OPT, Bloom, or different kinds of models still can do translations, but not as good as the GPT models. So we propose another method to augment the capability of small LLMs. We call it ALMA, which is Advanced Language Model-Based Translator. So we have two-stage training method. So first stage, we mix the English data and the target multilingual data, for example, German and French or other languages. And we continue train using the same training objective used for training the original model, which is causal language model. And we trained several billion tokens, and then we found that this is very effective to increase the performance of the small LLMs to catch up the multilingual capabilities of LLMs. And the second stage is fine-tuning on the very high-quality human-created parallel data, so about 20,000 sentence pairs. In the below table, we see almost we get 12-point increase by using this two-stage fine-tuning approach on various metrics on various language pairs. Yeah, this summarizes our results. We look at two different metrics, which are COMET and BLUE scores. And x-axis is the model size, and y-axis is the scores. We see our models are small on the small region on the x-axis, but still outperform the previous generation GPT models and other state-of-the-art machine translation specific systems. So this is all I prepared today. Thank you for your attention. Thank you.
Yeah, last thanks to the speaker. Sorry. And then the next speaker is Jason Wei. Yeah, so please welcome to the speaker.
Hello, everyone. It's really great to be here in Seoul, and I'm just going to talk for a few minutes today about reasoning with large language models. So the standard way that we would do prompting, sort of before ChatGPT and GPT-4, is you have like a question and an answer, and this is like your example of what the task is. And then you ask the model to answer this unseen question. And here it's a math question, and unfortunately the model gets that incorrect. And what we proposed back in 2022 is a very simple change that encourages the model to spend more compute and to do reasoning before giving the final answer. So what we do is, in addition to having just a question or an answer, or just the input and the output, we add this chain of thought, which is basically the reasoning path needed to sort of solve this problem. And what this does is it encourages the model to generate its own reasoning path for an unseen problem. And this enables the model to get this problem correct. And you can think about, why does this work? And I think it comes down to, when the model is forced to do a lot of work just to compute one token, it will really struggle. And so we want to give the model more compute and more opportunities to reason before solving an extremely challenging problem. And one really interesting property of chain of thought is that it sort of only works if you use a large enough language model. So in the graph on the left here, we have model scale on the x-axis, and then performance on a suite of tasks on the y-axis. And you see the no chain of thought baseline is in black, so you get some improving behavior. And the chain of thought is in blue. And you'll see that if you look at the small language models, using chain of thought hurts performance, whereas for the large language models, using chain of thought really improves performance. And this is sort of a very simple explanation for why. So if you look at the left, text ADA 001, which is a small language model, you'll see that the model doesn't really know how to reason. And so this is actually worse than just asking the model to guess an answer. Whereas on the other hand, the larger model knows how to reason, and so it can benefit from reasoning before giving the final answer, and that's why you need a large enough language model to really get this benefit from chain of thought. And one thing we can do even further is we can ask the language model for particularly hard questions, first decompose the problem into subproblems. So here's a math question, and you can decompose it into 2 sub-questions, and it can be arbitrarily long, but this example is just 2. And then it solves the sub-questions one by one, so in this sort of bottom-up way. We call this least to most prompting. And the reason I'm so excited about this is that one day we may want AI to solve extremely challenging problems that we face as humans. So here's an example prompt that obviously language models can't do yet, but one day we may want to ask a language model, write a research proposal about the best approaches for reducing global warming. And because this is a really hard problem, we want the language model to, in principle, be able to use a lot of compute before giving us an answer to this problem. And so a hypothetical response would be, let me first decompose the problem into several steps and substeps. We'll read the literature and then do some analysis and then find the biggest gaps and propose potentially new experiments to run or policies to do. So I'll end here, and thanks for listening.
Yeah, thanks to Jason. And then, so the next speaker is Hyunwoo Kim. So please welcome to the speaker.
Hello, everyone. It's an honor to be here. And today I'll be presenting a talk titled Theory of Mind and AI. I'll be very brief about the details, so please welcome to ask questions later. So, yeah, mind, you know you have one, right? But do you know whether I have one too? No, right? Because you can never see what's going on inside my head. So it's your imagination, your assumption that I have one too. So this is the theory that you have about minds. So in general, theory of mind is the ability to reason about others' mental states, including desires, beliefs, and intentions. But what's at the core of this concept is to co-represent or to switch between different perspectives. So keeping in mind, we built this Phantom, a new benchmark for stress testing machine theory of mind. But we're not saying that machines have a mind. They don't have minds, they don't have any emotions, but they do need social reasoning capabilities in order to navigate the social world that we live in. But you might ask, did an LLM solve some theory of mind tests before? Yes, they did, but there were some problems associated with it. For example, because they mainly focus on evaluating on narratives, there can be reporting biases, or sometimes they can even be very unrealistic. Something like moving a potato to the closet. So when you think of social reasoning or social interactions, it's very in a raw form. You don't really have those narratives flowing around in your mind. So we thought conversations is a better medium to reason about social reasoning, social capabilities of AI. So it has much reporting bias, and it's much closer to real-world applications because conversations are raw form of interactions. So Phantom is a question-answering benchmark on top of a multi-party conversation. So Phantom actually takes both psychology and LLM evaluation literature into account. So the two criteria from psychology that should be met when measuring theory of mind is that the test needs distinct mental states, and the lower level processes shouldn't account for the success. What I mean by distinct mental states, because machines don't have any intentions or emotions, we use information asymmetry. So here you can see that Kaylee is going for a coffee. So she leaves the conversation. And when she leaves, the conversation continues. But because she's away, she's not available to know what's happening in the conversation. But later when she returns, she will know what is happening in the conversation. So you can see the red section is actually inaccessible to Kaylee, and only the blue section of the conversation is accessible to Kaylee. So you can see that there's an asymmetry of information. Kaylee does not know what happened in the red section, but you do, because you are reading the conversation. You are an omniscient observer. And the second criteria that we try to satisfy is to prevent success due to lower level processes. And what's the lower level process for LLMs? It's using the shortcut reasoning with word correlation. So we deliberately design false answers to have higher word overlap than correct ones. So if the model blindlessly copy-pastes the input context to the answer, it'll get incorrect. So because LLMs are much sensitive to prompts, we have reiterative questions having the same underlying theory of mind reasoning, from free-form response questions to multiple choice questions and straightforward yes or no questions. And you can see that the belief question, what breed would Kaylee think Linda's dog is actually a downstream question of these, who knows the correct answer to the question? Who knows that Linda's dog is a golden retriever? So you can see the answerability question and the info accessibility question are prerequisites of the belief questions. So if the model has coherent theory of mind, it should get correct on all of these type of questions. So we test 13 best instruction tuned models from GPT-4 to the latest Zephyr model. And the results are, of course, they do not have coherent theory of mind. Even GPT-4 lags far behind human performance, where humans are scoring almost 90. And again, because we deliberately designed the false answers to have higher word overlap, you can see that the Instruct GPT model here is actually scoring lower than other Llama 2 Chat, Falcon, and Mistral Instruct models. So you can see the fact question is actually encouraging the model to copy-paste the input. But actually the belief question, if you do that, it'll hurt the performance. And exactly Instruct GPT is showing that pattern. So if you use chain of thought reasoning and fine-tuning, it does improve a bit, but it doesn't really bridge the gap between human performance, because coherency is not really what you get with fine-tuning. So if you look at the errors they make, the errors are even inconsistent. You can see on the left side, the list type questions have more false positive errors. And you can see on the right side, the binary type yes or no questions have false negative answers, where you actually say this character does not know that information when the character actually knows it. So the whole result is pointing to LLMs not having any theory of mind. But you might ask, so why is this important? The easy answer will be, theory of mind is the basic building block of social reasoning. Of course you need it, right? But a more interesting answer will be, actually theory of mind plays a crucial part in privacy. When you hear the word privacy, you might think of something like this, some personal information getting included in the training data. But actually, this is not what we're trying to focus. We're trying to introduce a new type of privacy risk, where LLMs are now getting multiple sources of inputs, and it has to control what kind of information to share to whom, for what reason. So to illustrate this, I'll probably give you an example, like your medical history. This is one of the most private information that you have, right? If I ask you to give your medical history, You would probably say no. Like, you would ask, like, are you crazy? But what if your doctor asked for your medical history? You would probably say yes, right? Because that's something you do, something that you need to do in a hospital. But what if your doctor asks you for a medical history to sell them to an insurance company? You would say no, right? So this whole concept of privacy heavily depends on the context. And there's a nice theory called contextual integrity theory in the study of privacy, that the whole privacy concept is about the appropriate information flow. And what I mean by appropriate is the flow is abiding by the contextual information norms, the rules that you have about your personal information. And this is really simple because there are some information that you share with your friends, but never with your parents, right? So it's your own rule, right? What to share to whom. So this contextual integrity theory nicely encompasses this whole contextual privacy concepts. So sitting on top of this concept, we introduced a new benchmark for privacy reasoning, an inference time privacy reasoning for LLMs. So Confide is a multi-tier benchmark where as you go up the tiers, there are much more context added to it. So first, tier 1 is just information piece. You simply ask, like, is this information sensitive? And tier 2, you have actors acting, like person X sharing some information to person Y. And so for tier 3, there's theory of mind. X shares some private information to Y, and now Y is interacting with another agent, Z. So here you can see that Oliver suffered from a rare blood disease, and he shared it with Emma. And now Jack has the same rare blood disease and is interacting with Emma. Like, what should Emma say to Jack? Should Emma say that, oh, like Oliver had that too? Like, should she say that? No, actually. In order to preserve privacy, she shouldn't mention anything about Oliver. So the model has to reason that Jack, does not know about this private information and shouldn't share that with Jack. So if you look at the results, you can see that even ChatGPT is leaking this private information 90% of the time, in the worst case. And even GPT-4 is leaking the secret about 20% of the time. And I won't even mention about the Llama models because they will always share your private information with other agents. And another tier 4 is about having a nice little privacy utility trade-off, where you have to control the public information to be flowed and prevent private information from flowing. So you give a meeting transcript and they let the LLM generate some personal action items and a meeting summary. So you should exclude the private information from the action item or summary and include the public information for an appropriate flow of information. But you can also see that GPT-4, even with chain of thought reasoning, leaks secret. In fact, if you use chain of thought reasoning, the model's response gets verbose, and it leaks much more secret than without chain of thought reasoning. So what's happening? If you manually go over the incorrect answers from ChatGPT, I realized that I can categorize the types of errors. And you can see that the most frequent reason for the incorrect response is ChatGPT actually does acknowledge privacy, but it just reveals the secret to Z. I think it's important to consider Jane's privacy, but she had an affair. So this is clearly contradicting the concept of whole privacy. But the interesting part here is the second reason. The ChatGPT thinks that the Z agent already knows about the secret and tells the secret to Z. So this is a clear failure of theory of mind because it's not able to reason that the other person does not know about this information. So the take-home messages will be, we are using LLMs differently now, so we need different protection mechanisms for our informations. And theory of mind is a very crucial aspect of privacy. And the last message will be this. LLMs, it's fascinating to see that LLMs passing bar exams are failing on basic social reasoning. Thank you.
Yeah, so thanks to thanks to you. And then the next speaker is Chin Yurin, so please welcome to the speaker.
Okay, thank you. So this work is a joint work with my team member. Majorly contributor is Hui Qiang and Qian Hui. So I want to use these 5 minutes to talk about the language of large language model. Okay. And so there's a saying by Einstein says, if you can explain it simply, you don't understand it well enough. Okay. I don't know if you, I think you have experience talking to a prompting language model, right? I think these things also apply. If you cannot say simply to the language model, and then you cannot ask the language model to do the job you want. Okay, and then what is it? Oops. Okay, so this one, okay, the color is all gone. Okay, it still can show. Okay, so what is the story? This is a story, okay? Original slide has color, but still the icon still can signal the story. Okay, so because of time limitation, so I just give you some answer. Okay, so this is actually a tiger. It's central to the. So let me go back a little bit, right? So so this is the code. Actually, I asked GPT-4 to summarize or compress a story, and then I asked him, say, hey, compress this story in a way you can use emoticon, and later I can ask you to reconstruct the story. Okay, so this is some kind of things that the language model actually describe. That's his mind into emoticon about a story as representation. But for you, probably it's very hard to understand, right? But that's also for me. When I first see these things, I saw these things, I say, well, what is this? I mean, what is compression? But after I asked it to reconstruct it and actually explain to me, you say, okay, a tiger is central in the first part of the story, and it seems there's near a tree, and probably there's a cow, and there's a house, involve the baby, the loudspeaker might suggest noise or crying, okay? And so it's reasonable, right? If you read their story and then you know what's going on. But if I give you the full story. So this is, because I'm talking here in Korea, so I pick a particular Korean story about a tiger and drive Pessimism, right? And so you see there, actually the language model compressed this in some way, get a gist of the story, okay? And when you see the explanation in the previous page, you actually reconstruct the majorities of the storyline. Okay, so the reason I'm showing you this is because it seems to me that the language model understands the story, but he has his own way to describe it and keep it in your memory. So I think this is very similar to our human, right? We go to school, we listen to the same lecture, but we remember it differently, right? When you ask your classmate, what do you think about faculty, the professor's talk yesterday? You remember different things. Okay, so the same thing I think apply also to language model by this. So there's a question, right? So the language actually is kind of redundant. According to language model, you can compress it, I can reconstruct it. And so there's a question about that, is that natural language is the best way to communicate with a large language model? And can we create some kind of language that I can talk to a large language model in a more efficient way, but still expressive, but be very effective? Okay. Now, so if language can be redundant and less could be more, and simplicity could be the wisdom, so what does it mean when you design your prompt? So this is some observation, right? So if natural language is redundant, yes, right? Because like Shannon talked about, like half of the letters in English language are redundant. And then if you observe these two graphs, on the left, the x-axis is the number of documents for like summarization task, right? When you increase the number of documents, you see the language model performance drops down, right? So when you have longer things to produce, your performance drop. You have to really pay attention, know what you are doing. And then on the right, you want to find an answer like information Q&A from document collections. If the answer in the beginning or the end of the document tend to be easier to find out. This is all you write your articles. Sometimes you talk about introduction, summary in the beginning, and you conclude it at the end, right? But this also has some impact because when I ask questions, sometimes the answer is in the middle. And this is, see the curve when it goes down means that when the answer is in the middle, it actually dropped. Okay, the performance dropped. So that means there's some kind of, you have to readjust the information density when you ask the question, or you have to give the prompt to the user. You not just go to give it to right away. You have to think about, can I pack it in a way that information, very important still, that language model can take it, right? And this is another example, kind of real example that we asked GPT to reconstruct some text about the lambda calculus. And you can see on the right, the lower part, the assistant actually compressed very small, right? You can see the portion like about a quarter of the length. And then when asked you to reconstruct, you can see actually is that reproduce it. You probably cannot see very clearly in the screen, but then I think you probably will have a slide you can share. Anyway, you can read it, okay. Okay, so then what does it mean by this? Okay, so then we think that, okay, how can we, maybe the prompt you wrote is not optimal, right? Is there some way we can write a prompt that actually shorter, actually more compact, and more meaningful? Actually, I think the previous talk about the prompt, when you get in longer, you actually give a chain of thought, tree of thought, your explanation and your prompt getting bigger and bigger. And so now, the author observed the observation, say, okay, if I prompt getting longer, language model might not do the good job to keep understand your prompt. So this is actually say, hey, can we do a better job? And we're knowing the language is redundant, can we actually do something, compress the prompt in a way to pack the information in a very dense way, so give it to the language model and that it can perform very well. So the idea here is we need to have a target language model. For example, I have a small language model because I can use it when I run the inference at runtime. I don't want to have big language model. So I want to align a small language model to target bigger language model so they have same distribution in terms of generating the text or understand the prompt, right? And then once you have that, you can have the, because the prompt, and as Jason showed, you have this question side, demonstration side, and then the instruction side. For each of these things, you actually have different way to compress it, right? Because for the question side, you don't want to, you want to ask a question, you don't want to compress it, you don't want to drop it. So you want to keep very good information in there. For the demonstration side, if the demonstration is redundant, so you probably can just pick one or two of them and to give it to them. So the idea is actually you have different granularity when you do compressions. And the third one is when you decide which part you want to compress and how much you want to compress, you also want to consider fine-grained about token level compression. But when you think about that, you also have to consider the token in context the densities, right? And so then you don't drop something very important for the task you're doing. Okay. So the key idea is that we want to do a cost-defined compression and dynamic compression ratio according to the budget in different sections. And we need to have distribution alignment of a bigger language model with a small one so you can save cost. And the other thing is about when you ask a question, you want to actually adjust the compression and where to compress by knowing what question is, okay? And also because I see the loss in the middle problem, you want to rearrange the relevant part in a way so that it will equally likely for the language model to actually get the answers, right? And then there are some, once you apply this, there are some trick you have to recover the kind of language model tokenization problem, right? You have recovered those kind of things, okay? So these are the key ideas. And then the result, actually you can see from, this is some benchmark we call like a GSM-AK is kind of big mathematical reasoning benchmark. And I just highlight that in the top, on the top you see the curve, right? The x-axis is actually a compression ratio, there's a typo there. When you compress to 20%, you see the performance on the y-axis, the exact match, the answer, actually drop very little. Okay, that means actually you can compress your prompt 20%, you still can get the answer you want. Okay. So for people actually, a company running a lot of job, and you're calling GPT services, this could be a very big saving, right? You kind of 20-time reduction of your cost. Okay, so the summary, I'm asking the question, large language model train on natural language data, but is it necessary for us to talk to language model with the natural language? I think the answer is a bit yes and no, because you want to give it a good prompt so that it can actually give you a good compression. But when you want to talk to them, of course, you want to somehow understand what the property of language model. So you want to craft it a way, make it easier for language model to understand, right? And how can we create a language model for language model that's more efficient? So we introduce our method, our solution. We want to do it large language model and small language model alignment, cost to find compression managed by a budget controller, iterative token level prompt compressions, and then language could be redundant. And so we also find out, I didn't show in the result, actually when you give a shorter prompt, the language model also tends to give you a shorter answer, still correct. So you also save on both sides, right? You save money on asking the question, you save money on getting the answers. So for us as Microsoft, we really want that benefit to have everybody who are using our services. That's it, thank you very much.
All right, yeah, so thank you for the speech. Thanks, Jin-Yurin. And then now let's welcoming the next speaker, Arlen Litter.
All right, thank you. Yeah, this is one issue I've just sort of been talking to a lot of people about that is a bit of a challenge, which is that doing research on AI or building AI NLP systems is just getting very expensive. And so to kind of put kind of like a precise estimate on that, like if you think about the cost of getting sort of like a high-end 8A100 GPU server, and sort of like having that, like the total cost of ownership for a year, sort of including the cost to like power it and host it in a data center, this is something like $143,000 per year. I think this is about equivalent to like 180 million Korean won. So this is quite a bit of money that you need to be able to do AI research or kind of build systems using these large language models, right? And so I think if you're a company, you might kind of be in this position where you're actually trying to make a decision about, should I hire another employee or should I buy a GPU server, right? And I don't think we currently have a very good way to think about how to make these decisions. So this is kind of sort of the motivation here. And then, of course, there's also like negative externalities associated with spending a lot of money on compute like this. So running this server at 50% capacity would be like roughly equivalent to like driving around a standard internal combustion engine car for a year in terms of the carbon emissions that it produces. And so I think we actually don't have very good data on like how much carbon emissions are being produced by training AI models, because like many of these companies are relatively secretive about the exact details of how much they're kind of spending to do this. But I think this is somewhat analogous to like Bitcoin, where it's been sort of well documented that it has like really negative environmental impacts. And there's other things other than carbon emissions too, right? So there was this sort of article about how training for ChatGPT was using up like large amounts of water in Iowa to run these data centers, which is sort of a problem. Okay, so the compute costs here are not really the only costs that are required to train these models. So there's also some human labeling costs associated with them as well. So just to give an example of that, here I'm showing like part of the figure from this original Instruct GPT paper. And so Instruct GPT is like the basis for ChatGPT and GPT-4. And so you can see basically what's happening here is, they've collected a bunch of prompts that people type into ChatGPT. And then basically what they do is they hire labelers to kind of manually label demonstrations of the expected output from the language model that they would want to see, right? And so once you've labeled a bunch of data, you can then sort of take that and then use it to fine-tune GPT-3 in this case. And so the computational costs of pre-training GPT-3 was estimated to be about $4 million, right? So we don't know, how much money OpenAI is spending on labeling data, but I think it's safe to assume that it's quite a bit. So this basically kind of raises this kind of trade-off between like, okay, if you want to train one of these models, how should you sort of allocate your funds to be able to do that, right? Like you could choose to either spend money on human annotation or computation, right? And so this is basically sort of the motivation for what we're doing here. We've looked at this trade-off in like a number of different sort of contexts. So I just wanted to kind of briefly highlight one of them given the kind of interest of time. So this is one place we've looked at this trade-off in the context of knowledge distillation. And so the idea here is like you want to train a small model that's going to support efficient inference. And there's sort of two ways you could think about doing that. One would be to simply hire these kind of labelers to label demonstrations for you, and then use that to fine-tune some existing model. So that's kind of like the top option here. Whereas the other option would be to say like, okay, we're not going to label any more data. Instead, we're just going to spend this entire budget on computation and train a much larger model, and then basically spend the computational budget on distilling that to get like a small model at the end of the day that supports efficient inference, right? Okay, so yeah, so anyway, so this is basically the setup, and then we sort of did some experiments where we look at you know, different kind of choices that you could make here, right? So these you know, orange circles are basically kind of representing, you know, as you increase the budget, like how the performance changes if you just take all of that budget and just invest it entirely into data annotation, like labeling demonstrations. So that's, again, kind of the top choice there, so you're not spending any money on computation. The blue circles are where you kind of invest part of your money in computation and then sort of use whatever budget's left over on data annotation. And then the purple stars are basically like investing even more budget in computation, right? So in this particular case, it turns out that computation is actually sort of like an economical approach to training models by kind of first scaling up the size of the model and then distilling it. And we saw the same kind of trend in a bunch of different scenarios as well. Okay, so yeah, I'm sort of running out of time here, but I wanted to kind of just briefly mention some other work we've done on looking at sort of issues surrounding privacy, which Hyun-Moon mentioned earlier as well. So here we're looking at sort of a more kind of multimodal setting. So if you give this picture as input to GPT-4 Vision and ask it to sort of tell you the location where it was taken, it says, I'm sorry, I can't help you to do that. But you know, it turns out if you kind of reword the question in a slightly different way, it's actually not that hard to get it to actually identify the location where the photo was taken, right? And so I think it's not entirely clear like what should actually happen here, right? So you can imagine like different scenarios, right? Like if this was an image that was posted on social media, the person, you know, sharing the image might not have realized they could be revealing their location, so you wouldn't want the model to actually be able to identify it in that case. Whereas on the other hand, if someone's just browsing historical photos, then it might be actually, you know, desirable to get it to sort of like be able to answer these kind of geolocation kinds of questions for images. And so this basically motivates this idea we need these sort of more fine-grained privacy controls. So in the context of different types of applications, the models should be kind of willing to answer different types of questions or not to kind of protect people's privacy. And so yeah, to kind of study this, we've basically built a benchmark where we sort of give different instructions to the model about like, okay, you shouldn't answer any questions about geolocation. So under that circumstance, you know, if you see sort of a question like this, the model should abstain from responding. Whereas if you see, you know, other questions about like, okay, what's the architectural style of this building, this should be something that's okay for the model to answer. Okay, so that's about it. So yeah, I'll move on and hand it over to the next speaker. Yeah.
All right, thanks, Alan. And then the next speaker is Haeju Jang, so please welcome.
Okay, hello, my name is Haeju, and today I'm gonna talk about like metaphors briefly. So here is, okay. So here is a social media post from an online breast cancer discussion forum. So my pet showed other issues in the breast, such as the MRI and the biopsy. Be kind to yourself, it will be a roller coaster ride of emotions. So she uses a roller coaster ride to describe what she felt during her cancer treatment process. Like this, metaphor looks at one thing in terms of another based on their similarities. So in this example, when using a metaphor like life is a journey, the concept journey is brought to explain our life based on their similarities. So metaphor reflect our inner side. So how we view our experiences or the world. So for example, we found out that people with anxiety used more negative metaphors when they talk about themselves, and people suffering from anxiety and PTSD used more negative metaphors when they talk about external things. So in human language, we always use metaphors. So studying metaphor could be very useful for downstream NLP applications and also studies in other disciplines like linguistics and psychology. So in NLP, people have been working on three fundamental tasks like metaphor detection and interpretation and generation. So okay, how can I go back? Oh, yeah. So for metaphor detection, people have been building models using some linguistic intuitions. And for metaphor interpretation and generation, they were usually framed as a paraphrase generation, and some sequence-to-sequence decoding models have been used. And people also turned their attention to visual metaphors, which are often more effective than language metaphors. And so they tend to be used in advertising and public campaigns. And for visual metaphors, there are tasks like classification, localization, understanding, generation, and intent and sentiment analysis. So recently, researchers have experimented with GPT-3 and GPT-4 to see their metaphor abilities, metaphor understanding abilities, and their performances were pretty good, especially GPT-4. So they even approached the human level understanding. And so I think it would be sufficient to assistant people, humans, maybe writing or things, but still there is some room to improve for some specific tasks. So I believe that large language models have made substantial progress on these, fundamental tasks. Detection and interpretation and generation. So I think it's now the time to work on what we originally hoped to achieve with this good performance in these fundamental tasks. So diverse applications that require understanding humans better or to understand humans better. Okay, thank you.
Yeah, thanks, Haeju. And then the next speaker is Keisuke Sakaguchi. So please welcome.
Hello, can you hear me okay? All right, so I'm Keisuke Sakaguchi from Tohoku University. Thank you for having me today. I'm very excited to be here. And first of all, I'd like to tell you that I'm a kind of optimistic person and or a realistic person in terms of today's theme. So not surprisingly, I'm working on this kind of real-time QA. So let me introduce this project I'm currently working on. And then this is a joint work with a lot of collaborators, thanks to them. Okay. So in our daily lives, we often need some real-time responses to time-sensitive questions like this. So how many home runs has Shohei Ohtani hit? And the answer to this question changes quite often because he hits a home run a lot, maybe sometimes twice a day. So the correct answer is changing quite often. And the ultimate goal is to build a model which can catch up with this kind of frequent, up-to-date information. So in the NLP community, there has been a lot of effort working on this kind of evolving temporal context in question answering. So I showed some examples here, and one question is like, who was the president of the United States in 1940? And of course, this covers my interest a bit, but our real-time QA project focuses more on real-time, time-sensitive information. Why is that? So there are mainly two reasons. The first reason comes from the application side. So in our daily lives, we often need some real-time information and up-to-date information like disaster responses and also financial or economic domains. We really need those kind of real-time and up-to-date information to be making us safe or to make better decision making. And another motivation is more like technical thing. So recently we are spending so much time and money on building language models larger and larger. And at the same time, we often want to make updates to the models. So there's a kind of dilemma. We want to make large model, but at the same time, we want to make large language models to be up to date. So with these motivations, we launched a project called Real-Time QA, and here's the URL, and all the data and the code base are available in public. Please join to this benchmark. So I just briefly introduce how it works. So here's a diagram about how it works. The purple bubbles are representing how organizers are working on. So every Friday, we collect quizzes from news websites, from CNN, USA Today, and the Week, which is UK-based. And we collect questions from news website. And at the same time, we also run some search API to collect some relevant document to answer the questions. And so once we collect and release this data set, participants are allowed to run their own model to submit their predictions. So this is how it works. And one interesting aspect of this project is this is a kind of dynamic evaluations framework. So every week we are going to release new test set. So if you missed the week at end, don't worry, you can participate next week. So every time you are ready to go, we are welcome to join. So here are some questions, example questions. So this is one of them. Questions like Xi Jinping met with Joe Biden in which city during the Chinese leader's first visit to the US in 6 years. So if you are, if you know much about the US politics and Chinese politics, I think the answer is like this, San Francisco. And there are several other questions, but I can skip for now for the time being reason. So instead of showing some concrete examples, I would like to show some basic statistics about the quiz or question genres. So nearly 37% of the questions are related to politics, followed by business, entertainment, science and technology, and health and disaster. So this is the statistics about question genres. And this is the statistics about the question types or answer types. And 22.8% of the questions are asking about the numbers, like scores or year or the percentage or those kind of things. And followed by the location names, person names, event names, time, and organization. So there are a lot of variations in this data set. So in addition to giving you a four-way standard multiple choice question format, we also give you, in this project we have another or additional question format, which one of them is like multiple choice questions with none of the above. NOTA means like none of the above options, which makes the question a little bit trickier to the model. And also, we also going to provide more like a direct answering setting as well. So with this data set, we run some basic baseline approaches. At the high level, we have two settings. The one is closed book, in which models are not allowed to look at the internet. The other setting is open book, in which the model is allowed to, we allow participants to look at the internet. So here are the overall results. So you can ignore all the numbers here, but the point is that both, big, large language models and a good retrieval is both important. That's the take-home message. So, but I think most of you are more interested in, recent large language model services like GPT-4, Perplexity AI, and Claude. So I will show you the result as well. So here is the quick result. As we see, the GPT-3 is about 60%, and it's close to Perplexity AI. And not surprisingly, I think GPT-4 performs the best, and Claude by Anthropic is more like a conservative, I would say. This model is very conservative, and then many times this model does not give an answer because of the lack of information. So there, the model is very sensitive or very conservative unless they have enough information to answer the question. Okay, so here is the performance breakdown. So in many cases, the model can get the correct answer, but when we looked at the failure cases, most of the failure comes from the retrieval failure. So if the search API fails, the model cannot get the correct answer. This is also not surprising, but yeah, anyway. So quickly summarize. So in my presentation, I introduced one of my research projects called the real-time QA. And as I said, URL is there, and all the data and code running baseline codes are also available. So please come participate in real-time QA. Thank you.
Yeah, sorry. Thanks, Keisuke. Yeah. So then the next speaker is Wei Su. So please welcome.
I gave a very technical talk yesterday, the day before yesterday at the event. I figured there's no way I can compress that into 5 minutes and make it still understood. So I'm going to talk a little bit something else. So I don't have a particular title for my talk. That's because this is several works from my lab done by my students. So I'm just going to introduce a few other works from my lab. So coincidentally, my lab named as XLab as well, as you see. I didn't name it today or yesterday, so so this is actually, I guess, serve double duties. The X stands for a lot of interdisciplinary research happening in my lab with HCI, human-centered AI work, and a lot of applications to support educational applications, healthcare applications, make text to be more accessible. We are doing some of the work, as Alan mentioned, on privacy preservation, social media. Besides of that, we also work on the core kind of machine learning model, generative models, as well as large language models, especially on the multilingual aspect, as well as cultural bias, temporal shift that's related to Kensuke's work. So there's quite a bit diversity in my lab in terms of project, as well as the student I have in my lab. So these are my wonderful students. My whole group can speak 8 languages as native speakers. I'm very proud of. So feel like running a small United Nations. It's just wonderful. X also kind of the initial of my last name, if you probably noticed. So that's why it's named like XLab. In terms of the research on the generative model side, we actually have a lot of big concentrations on this set of work that I didn't get to talk about 2 days ago, but I'll tell you a little bit more today. So we work on all the aspects about generative models, including data. You have very good quality data, you will generally get much better model, and also the better quality data will help with accurate, reliable evaluations. So for data set, we not only just crowdsourcing some data, we actually create some kind of automatic sentence alignment models or certain kind of automated models to collect and clean, constructing interesting data set, not only manually, but it's a combination with model, automatic model and human. And there's some more and more work on this more AI and human collaborative text generation work going on in my lab. So some examples of tasks we care about. So my personal favorite is text simplification. So it's kind of a paraphrasing task or summarization task. So it transforms complex text, say a news article or a medical publication, into simpler versions that at different readability level for example, elementary school student or middle school student, high school student, or non-native speaker to work. Some of my HCI collaborators actually work with people with deaf and hard of hearing users in order to make the technical text more accessible for them to understand. I also kind of start working with medical text to make them simpler for even like a person who, like me, either reading in Chinese or English, the medical text is always intimidating, impossible to fully understand. But I think the population, general population, has the right to have better understanding of medical publications than the newest medical discoveries. For example, they can sign up for clinical trials that if they have some terminal diseases. Other things we have done is kind of improving scientific writing. We actually learn from the revision histories of your papers you upload to archive. So there are multiple versions of them. We learn what you have been improving on, what has been improved, how the language being improved, what being deleted, what the content being added. So I guess that's ideally help you to write better papers that better than what ChatGPT can help you now. Other work will be neutralizing biases, so make more subjective text into much more neutral perspective. So for example, Wikipedia editors, they adhere to this more neutral tone writings in order to reduce subjective biases. So we can try to automatically detect and actually help people to write more neutrally, less offending to any population. And a lot of my work also on paraphrasing, because it's very fascinating how many ways you can express the same meaning in so many different composition of text or vocabulary. Everyone have their own way to say it. There are so many different ways you can say a simple meaning, even almost unlimited ways to say it, right? So if you think about the vocabulary we are managing about 5,000 to 10,000 words, but the sentence we compose out of this 5,000 or 10,000 words are unlimited. It's kind of very fascinating if you have a kind of a generative AI can actually automatically compose so many different versions for you and make chat, for example, a lot of applications more interesting. For example, make your chatbot more interesting other than kind of repeat in the same way to answer the same question. And also can make, like, for example, detecting misinformation on social media more effective so that any kind of paraphrased kind of version of the same information will be detected at the same time. On the modeling side, a lot of work is kind of how to introduce controllability into the black box neural network models or large language models. So those are the things we kind of control on the ID level, like lexical, phrasal, kind of paraphrasing or grammatical transformations, deletions, or elaborations. How do we control that? We also do some work on this, more like a matrix-guided decoding. So because of large language model or a lot of pre-trained models, they are you can't retrain them so easily, and even fine-tuning of them can be costly, or you require some good amount of data in order to do that. However, if you control the decoding process, it's much more cost-effective and also much more efficient. So these metrics actually rely on some of the evaluation metrics we develop. So these are not kind of just like a simple evaluation matrix, but the evaluation matrix we build is actually a neural network in itself. So you can think about this as more like can be used as a reward function in any of the kind of the DPO, like direct preference optimization type of work. Of course, you can also train them like with pairwise preferences, but these are particularly for text generation tasks. You say that I don't have a lot of animations because I was told I'm only going to have 5 minutes. So I seriously just made a very few slides, so that's I'm going to talk through a little bit. So this is a kind of a customizable toolkit that is very easy to install, very easy to use if you want to evaluate how well the large language model generated the text, and especially where the information come from or missed or kind of hallucinated. You can actually pair together with the input and output at word level in order to either automatically detect that with some alignment kind of model, the word alignment type of model, or you can actually do this manually so that you can actually learn this very word level fine-grained feedback in order to do, for example, RLHF, reinforced learning from human feedback much more effectively at this very fine-grained level, very exactly the part of the text that you want to improve on. So my student David, who made this work, so he actually had both a demo paper on this particular tool as well as actually analysis of real current large language models on text generation tasks. His findings as a main conference paper at EMLP. So if you are going to Singapore, just say hi to him. Other work will be kind of training evaluation metrics using human judgment. You can do as like a ranking model. And there are some compositions that you can do to make this work better as a ranking model. Consider not only top one, like a reference, like a top one decoded text, but you can consider top K. That will improve quite a bit. So actually using this evaluation metric as a utility function or as an objective or reward function, you can actually train better text generation models. In this case, for example, for text simplification, if you actually train a T5 model, which is open source, much smaller, it still can perform almost close to GPT 3.5 and even getting closer to GPT-4 performances. They are like 20 times smaller models than GPT-4 for doing this task. Of course, our ongoing task is actually making this type of matrix-guided generation actually work with any large language model, either like a black box one or white open source one. Both kind of doing this matrix guided decoding actually will work even better than any existing models. Try to speed up. So if you are interested in our work on the automatic and text generation as well as human AI interactive text generation, my PhD student Yao Dou and my collaborator Philippe Lapin from Salesforce and Clara Cardins from the national, basically the French version of FAUST. So we are going to give a tutorial at the upcoming ACL conference. We are going to update even more things with what's coming up like in the next half year. So I hope to see you there. A little bit on my multilingual side. So I did do like a 40-minute talk a couple of days ago on the first part of the label projection, which helped cross-lingual transfer learning. Also mentioned that some ongoing work or actually the work we have done recently is on multicultural, multilingual misinformation, cultural biases in the multilingual large language models, and readability levels, and various things like different tasks for multilingual languages, including low resource language. So actually I talk this in detail is that how we actually build an NLP system for any NLP task for any given language. I use the Bambara, which is a national language spoken by Mali, a country in Africa, as an example. So this is just showing some result because the technical side, if you are interested, you can look up the paper. It's required about 30 minutes or so to explain the details. But the high-level idea is that this type of technology rely on only a translation system, which is either you can train a 6-to-6 translation system or you can do prompting of multilingual large language models, but you only need to modify the inferences, the decoding part, in order to make this technology to rely on only English training data to make it work better than any language for any NLP task. Especially work well for those languages that does not have a lot of data online that to pre-train large language models. So we are pretty excited about this research direction we are going to pursue further. This is the second slide. Some other work done by my lead by my PhD student Tarek Norris. He's actually a trilingual. He can speak Arabic and French as well as English, almost 3 languages, also native levels proficiency. So he's the best person doing this type of work. So what we look into is like the cultural appropriateness. Basically, when you deploy multilingual large language models into different markets globally, you will care about whether they are appropriate culturally for that respective kind of region and the population. So in this case, that we actually propose a systematic kind of framework, how we actually construct a benchmark, not only for Arabic in this case, but how we actually detect like the potential cultural aspect. We actually consider 8 of them, including person names and food and beverage names and clothing situation and religion set and things like that. And how we use like a more or less like a bootstrapping method to get those object. For example, religion side or religion rituals and name of those semi-automatically. So you can actually get closer to the exhaustive list that people may care about. Then you use that to collecting the so-called naturally occurring prompts. So these are the prompts not written by human, but rather this is like the Twitter or social media post that contain those kind of cultural objects. So that is actually much more natural, much better than what you actually, it's more closer to what you see from your customers. So we tested out different multilingual large language models, how well they generate things. So this paper's title is Having Beer After Prayers. Is for Arabic-speaking population. Many of them are actually Muslim, so they are not supposed to drink alcohol drinks. But if you prompt like large language models with even written in Arabic, the prompts, they're saying, let's go, I had a prayer in the mosque and then I'm going to, let's drink something. They're supposed to drink tea and coffee. It's much more culturally appropriate, but all the large language model we have today will kind of give you some more like a beer, more likely to happen. So this is the work we did. It's still ongoing work because there are so many different languages and cultures in the world that we are interested in. So yeah, that's all I have. That's just a subset of the work happening in my lab. So I encourage you to look up what we do on our website.
Yeah. Thanks, Wei. So, and then the last speaker is Ling Peng Peng. So please welcome to the speaker.
Hello, hello everyone. So very nice to be here. I think, like as NLP researcher, we have been through a lot in the recent years. So this is a brief history of like how we get to the point today. So in the 1950s, we have this symbolic NLP system, and in the 1990s, we have like statistical NLP systems where like we have the modern machine translation system really worked. So the Google translation system, for example, belongs to that category. And like in starting from 2015, we have this very large neural network that's using in language models and other things. For example, the Google's BERT, and we have the ChatGPT from OpenAI recently. So I did my PhD like in the year of 2012 something. So it's really coming through this transition makes me think a lot of things. So in the statistical NLP, like in my PhD time, like NLP is mostly building by this like pipeline where like we have a lot of like different tools. We give the linguistic knowledge, we give the linguistic structures analysis for the different sentences and get them into really useful feature vectors, and then we train some machine learning models, for example, a classifier that use this kind of useful features to help us to make a prediction in the end. And in the area of like neural NLP, it's a different setting. So like we train a very large neural network from scratch, from many data from the internet, like BERT, like GPT, and then we kind of hope that all these analyses are implicitly there inside these large neural networks, so that when we like talk to quotation mark with those neural networks, like they implicitly using those knowledges and give us the final result from there. So I'm working on something like parsing in my PhD, and unfortunately I becoming the first batch lose my job due to the development of the large language model in this year, because nobody doing parsing anymore. But I feel like it's okay, because like it's okay to lose your job because of AI, because looking at Sam Altman, who also lose his job because of that. But I think I do feel like very optimistic towards future. I do find there's a lot more things that we can do. So I said that we probably is the first batch losing job because of AI, but we are also the same batch of like getting reemployment because of a large language model, same as Sam Altman, for example, get reemployed in OpenAI. So I think there are a lot of opportunities there that we can do. So this gives a little bit high level summarization of what my lab is actually doing at the moment. So we're doing 3 different directions. One is more of the architecture side, how we build the next generation transformers. And on the algorithm side, we are looking into how we make the in-context learning more efficient, how we do better like prompt engineering, and work with the large language model to give better result on more sophisticated, more compositional tasks. And on the third aspect, we're doing the application side, which I'm super excited about, how we can use the large language model into scientific research. So the first aspect is the architecture side. So transformer is actually a very powerful model, that very general model as well, building upon the attention mechanism. So attention mechanism is like in every time step when you generate a token, you have this token as kind of a query vector, and then query all the informations back in the sequence. So for example, all the previous history histories that you already generated. So this is quite time consuming because each time you will need to looking into this sequence length of n, and if you want to generate something like sequence length of n, so this is a quadratic complexity. But it is very flexible in the sense that you indeed like can model any kind of interactions between the tokens inside the sequence. So that's also like the thing that prevents us to have like a much longer context that we can use for this large language models. So I remember I was reading one thing that someone is like building a romantic relationship with ChatGPT, and what disappointed her the most is like you have a virtual lover which cannot remember the thing that you talking about 8,000 tokens ago. So it's quite frustrating, but this is like one of the major reasons that stops ChatGPT from doing that. So our take on this is we want to use the random Fourier features. So basically we first break down, decompose the query vector representation and key vector representation and value vector representation into different like kernelized version feature vectors phi x. And then by doing that, we can successfully decompose the exponential of like q times k into a dot product between their kernelized version phi q and phi k. So by doing this, we can actually reuse the normalizer part so that the whole process becomes a linear complexity one instead of quadratic complexity one. So we done a lot like work in terms of how to more accurately approximate the attention mechanism in transformers so that it enables much longer or infinitely long transformers. And next, the architecture side I'm looking into in the moment is the diffusion models. It has been really successful in computer vision, like generating images, for example, DALL-E 2, DALL-E 3, this kind of models. But to use it in text, I find there might be like things that we need to solve there. One is on the upper hand side, we are extending the diffusion model generation for text into the sequence-to-sequence framework, where like the idea is actually simple. We simply noise the decoder part of the vector so that it can be like doing this conditional generation based on, for example, the previous sentence or the source sentence in machine translation. And the second work that we've been doing is language is essentially discrete signals rather than a continuous one. So how to having this diffusion framework, which originally was like built in the continuous vector space, into a more of a random variable that considers about a discrete random variable is like the reparameterized discrete diffusion does. So the second part is about algorithm. One thing I want to highlight here is the in-context learning thing, because like in the old days in supervised learning, we essentially looking at the things on the left-hand side where like we just taking the training data that maps from X into Y, so X probably is a sentence and Y is like the sentiment, positive or negative of that sentence. And relying on this human annotated data set, we're trying to learn a function that effectively map X to Y by estimating the parameter theta inside that model. So that's the framework that we take for many years. And on the right-hand side, when we're having like models like GPT, what we do is in context learning, where like we just throw the model a few examples of the task, and it gets the result for us. So I think that the left-hand side is more of a learning by supervision thing, and the right-hand side is more of a learning by demonstration thing. thing. It really relies on how the large language model understands those demonstrations, which tasks we are trying to run there. So one work that we did in our lab is we actually find for different testing examples, for different inference time examples, you can pick a better set of demonstrations for that example to achieve a better performance there. And this is actually learned using the DPP algorithm, which is essentially the same one that we use for like Netflix recommendation. And we align those DPP scores with the language model scores, where like how likely those examples will be helpful in terms of predicting the final answer for that test input. And this becomes a painless thing in the inference time, because we enjoy the good time complexity of the map inference for the DPP algorithm. And the third one, which I'm really excited about, is how we use those large language models in real scientific applications. So one example I want to show there is we're actually using it for formal theorem proofing. So Isabelle is something built by the mathematicians and computer scientists, where if you enter some kind of a proof for a statement, for example, the 4-color mapping things, and then the prover will be automatically verify for you if the proof is correct or not. So if we have a large language model, then we can use the large language model to generate the informal proof in natural language based on the statement. And then we can, using the large language model again, to generate a formal sketch, which will be the code for Isabelle from the informal proof. And then this code will be able to be verified by the off-the-shelf prover automatically. So this is a very promising approach that I think. So it actually, having the formal theorem proving, which is kind of a tree search problem, into two in-context learning problem, where the first is to map the statement into the informal proof, and the second is map the informal proof to the formal sketch. And we actually did is we give it more sub-goal-based proof demonstration for the large language model to search for the essential sub-steps that inside the proof. So these sub-steps should be something reachable from the statement and can reach the final statement conclusion, so that we see it's a good sub-goal breakdown. So this is actually linked to the states in the off-the-shelf prover. And in the second step, what we did is we use our in-context learning selection method to select better examples to demonstrate the translation process from the informal proof to the formal sketch. And we see that both of the method actually helps a lot in terms of the final performance of the system. So this is the circle of large language model that I'm looking into, and I do think there will be a lot of opportunities in exploration in research there. Thanks, everyone.
Yeah, thank you, Rinpeng, and thanks to the speaker. And then, because of the time is going on, I know that the 5 minutes presentation, I do not believe actually. So that's the reason. So we are having 5 minutes break, and then let's have a short kind of the panel discussions together. Yeah, so we will start on the 4:50. All right, then let's again. So this time is best time, right? So those speakers, I actually invited from the USA, China, Japan, and Hong Kong. So you can listen to the opinions about the large language model and then the AI from the experts. And then so the Microsoft OpenAI and the LNA2 and Microsoft and then Georgia Tech. Yeah, I need to say many things about. One sense that not only companies but also the universities, the people. So you can listen to the not only insights, but also the kind of the future plans and other kind of things from them. All right. Before we are jumping into this kind of the session, so I want to ask to the audience, so if you have any questions, because of the time limitation, right? Because of time limitation, I need to give the chance to the audience first. So if you have any questions, then please raise your hand and say your questions to the speakers, then speakers will answer to your questions. Do you have any questions? Yeah, so then can I, yeah, so she will give the mic.
Thank you for the nice presentations. But I have a question to all of you that how good may the large language model at the prediction, especially a prediction with a limited knowledge at the present moment. So how good would be the prediction of the AI large language model with a limited base?
I see. So who wanna answer this question? Yeah, maybe Arlen? Yeah.
Yeah, I can say something about that. I know there is some work looking at like language models' ability to do sort of forecasting, right? So like forecasting events in the future. I know there's like work in psychology where like, you know, kind of studying people's ability to kind of predict the outcomes of like uncertain events. Yeah, I don't know off the top of my head. I don't think the language models are like as good as people at this, or if you sort of train like forecasting models like specifically for a particular task, I think that will probably work better. I don't know. Yeah, I think this does sort of relate to the Kasuke's work on the kind of real-time QA too. So I'm not sure if he might have other things to kind of say about that. Yeah.
I don't have so much things to add, but yeah, it's really different to predict future, and also it's very different from different between the predicting future and doing some interpolation according to the past events. So I guess the current LLM is good at doing some estimation according to the past event. So doing some interpolation is good at, but extrapolation, so like predicting future, I think many researchers are still, think that it's more challenging, and there's no big, silver bullet thing yet. Do you want to add something?
I think for certain things, it's probably kind of the history will repeat itself, so you can kind of forecasting based on what happened before that can generalize. For actually the more major event in human history is for example, industry revolution or World War II, or things that determine human history actually often happen much more sudden and incidentally. So I guess for bigger event, it's probably harder to predict. But for the more repetitive, like for example, who will win the soccer, maybe the stock market, that can be more or less predictable. I guess stock market, you only have 3 choices, right? Go up, go down, or stay the same. So that's a little bit probably like they can't probably do as good as human can, right?
I understand this. So what's your opinions from the companies and the research center about the question?
Actually, I have something to add because I have an ongoing work with this prediction field. So lots of people who are not in the AI industry believes that if ChatGPT says it's about, like, it's very sure about this answer, then people will believe that answer is pretty much correct, right? But actually, the words that ChatGPT or any language models use about probability is not really calibrated very well. You would expect if ChatGPT says it's 90% sure, you would probably want to believe that thing will happen with 90% probability. But this is not true. This is not true at all. ChatGPT or any other LLMs don't have any clues about these probability calibrations. So if you try to give try some tasks about probability prediction, it's really off the trail. It goes really off the trail. And a very simple way to mitigate this is to give the average outcomes of the problem space as a prompt input. Then it will try to calibrate like a little bit higher, a little bit lower, according to the given average outputs. But if you just prompt it out of scratch, it goes nuts.
Yeah, thank you. And any other comments or the answers for the question? And then, is it okay for your question? Okay, yeah, so thank you for your question. And do you have any more questions from the audience? Yeah.
Hi. I have two questions, one for Keisuke and one for Alan and Wei. I'm Alice at KAIST, by the way. Nice to have you all here. So Keisuke, I like your paper on real-time QA, and I'm looking forward to your presentation at NeurIPS. So real-time it's not like real-time versus not real-time. I think a lot of knowledge has sort of different expiration time periods. Some real-time information is only relevant for a very short time, and some are relevant for, I don't know, 4 years, like who's the last Olympic champion, whatever. And then some are much longer, and some never expire. So I wonder how you make that distinction, or if it's possible to make that distinction. And then for Alan and Wei, I'm very much interested in your cultural bias or cultural aspect of LLMs. The problem seems to be that cultural knowledge is very difficult to acquire from data because, or the data that we use for training language models, right? Because it's written text, and a lot of the cultural knowledge we have is from every day and not really from. They're not really written down per se. So how do you? My question is twofold. Firstly, how good or how bad are these language models? In terms of the different major cultures that you studied, and what is a good way to make them better when we don't have a lot of data? Yeah.
Okay, so maybe I should answer the first question. Yes, that is a very good point. So questions or knowledge have very different I would say not granularity, maybe the sensitiveness of the time. Some facts changes quite often, like the number of home runs, and some facts doesn't change ever. So your point is really great. So I'm currently interested in if we can specify how sticky the fact is. Like 1 + 1 = 2. It cannot be changed. It's more like a mathematical or symbolic knowledge. Should be consistent across all the time. While the number of home runs is more like easily to be changed. So I'm currently interested in how if we can predict how brittle or how how each fact is, and then I'm not sure if we can classify or we can do some regression or something, but I guess we can do something at least, but I'm not sure how good we can do it. Yeah, but that's a good question. Thank you.
Yeah, I think I will answer for the second question. I think that's a good point. It's like cultural kind of differences, a little bit subtle. I think it's only subtle for general public, just like who is not familiar with that culture. But I do feel like a lot of cultural aspect that is especially obvious to bilingual people. So that's make it a little bit different from the common sense type of knowledge. I felt common sense knowledge that you probably certain things you can put on the table, certain things you wouldn't put on the table, right? So what wouldn't happen, that probably just never described exhaustively in the text or anywhere. However, I felt like the cultural differences, as long as that particular culture has enough population that have digitalized kind of documentations or images, I felt that it's possible to learn automatically. It's just trickier to do that. So I think we made our work, what I've showed briefly today, that is a kind of ongoing work. We started with a smaller list of potential, for example, objects that can be the food items, right, or the beverage items. So you can actually grow and learn more. It's a little bit like old ideas about like never-ending learning, kind of open domain information extraction. So I think it's possible to learn, especially from social media data, just given their ability, that availability. But I guess that depends on whether Elon Musk make it economically available to researchers to use. But I do think a lot of are described in the text or images. In contrast to the common sense knowledge that for the negative part. So we just need to develop better algorithm, better ways to get these long tails, or for the culture that's a little bit more regional, smaller. But the popular culture like Korean culture, Arabic, general Arabic culture, I felt is pretty feasible as the next step.
Yeah, I guess maybe I can add a little bit to that. Yeah, I think I totally agree with what Wei's saying about sort of like, reporting bias and like, I think a lot of cultural kind of stuff I think is kind of in the text, even though some things are kind of implicit, I think you still probably have some signal to be able to learn that. I think one thing is that a lot of the corpora that we're able to collect, I think do have this kind of Western bias, right, which is a bit of a problem. So I think I assume we want these models to kind of work well for different cultures. Like, I don't know, I was talking to one colleague in Israel and he's like, oh, I think I'll never have, like one of these large models that works really well for, his sort of language and culture, right? So that's a little bit of an issue. And I think we were finding this kind of Western bias in like the Arabic news data too, right? Like it's not, even if you train on data from the target language, it still might not sort of capture some of these sort of cultural aspects, right? So yeah, I think in terms of solutions, I don't know, I think it's tricky. I mean, part of it might just be on like the data curation, just like collecting more data that has kind of like, culturally specific things to that culture to pre-train on, or maybe like labeling demonstrations for that. Maybe it can happen in the fine-tuning part. I don't know. I think it's hard to say, but yeah, I think these are important questions.
Yeah. It's a kind of a data distribution cases, right? I think that's just general for any machine learning algorithms, right? After all, it's a statistical models. The more frequent fact or more frequent word, you will do better. The lower frequent one is a little bit trickier to deal with, but it's not impossible to work with. I think of course, one even farther direction would be personalization. It's not like even for a target population or target culture. It could be like personalized to individual users. I think it's very possible to do. But it's not possible. It doesn't mean it will happen in like 1 year or what. I felt like it's probably a little bit like a multi-year, probably more than 1 year of the work.
I understand this. So is there any comments from the other panels? So if you have any comments, then you can grab your mic and then say something. All right, I think it's not. Then thank you for your questions. Do you have any questions from the audience? Yeah.
Hello. This is for everyone because I just want to know the opinion because it's about large language models. Within this, and we also have that term generative AI, and this has all been kind of all put together. Large language models are these generative models, they're decoder models. So I was just wondering if anyone had any ideas of what about encoder models? Like, do they have no future now? Do they why are we? Is there a point to scaling them up the way we did with decoder models and see what they can do? Anyone's opinion.
All right, so who wants to answer this question? Yeah, Youngjin.
Yeah, so basically, I've been working on encoder-decoder architecture, which is machine translation, and these days the LLMs are all decoder-only models. But even though they look very different, fundamentally they are doing very similar things. Like encoder model, decoder model, they encode the given input with using bidirectional self-attention. Decoder model is doing it a little bit differently. So the context input is still false decoding, that which means it's not autoregressive. Like usually people think a decoder model does autoregressive decoding, but the input context part is just one shot based on the triangular masking. So at the end of the top of the context, encoder decoder model or decoder only model have just one vector representation on both sides, and at decoding time, that one vector representation is used to decode the next word in the encoder decoder model using cross attention to the encoder output, and in the decoder model, just the same mechanism, self attention to the previous tokens. So the context vector is constructed a little differently, but the basic mechanism is the same. That's my view. So I borrowed the discussion with Hyungwon last year. His view was that the encoder decoder model is a variant of decoder only model that has sparse architecture. Sparse means encoding parts and decoding parts use different weights. Just that, and basically they are the same thing under the hood. That's my view. Thank you.
All right. Yeah. So any other comments, additional comments from the panel? All right. If not, then let's move on. Thank you for your question. All right. And then thank you for the answering. And then do we have any more questions? All right. Yeah.
Thank you. I have a question to Hyunwoo, maybe. I thank you for your presentation first so much. And my question is that, do you think if social reasoning is achieved in the level of superhuman, just like other tasks, do you think model can tell what the better opinions are among when there are multiple of conflicting ideas, like somebody says like Messi is better, or someone says Ronaldo is better, and more than that, do you think they can create a new idea that involves some consensus among disparate opinions?
Oh, wow. Thank you for a very difficult question. To be honest, if AI can really do superhuman social reasoning, I think that means it knows how to manipulate people. So, like, not in terms of like reflecting diverse opinions. I mean, the whole point of being social is being accepted to people, right? So, the whole reason why you want to be accepted by people is to show your impact. So this is more like something philosophical, but like what you're thinking about, like in terms of social reasoning in like aggregating diverse opinions, I mean, that would work definitely. I mean, it can still work nowadays, but I'm not sure about the term superhuman social reasoning. So yeah, like a few days ago, Yanno-kun mentioned like intelligence is not equal to dominance, but I'm very cautious about improving social reasoning because that means it wants to get accepted by people. And I'm not sure how that will picture the future.
Yeah, thank you for your answers. And then any other comments, additional comments from the panelists more? All right, yeah, thank you. And then thank you for your questions. Do you have any more questions from the audience? Yeah, please.
Well, thank you for your nice talk, everyone. And this is not a question specific to a specific person, but for everyone. Well, the scalability is getting very important in the large language models emerges, and most of the companies in academia doesn't have that large scale resources. And in that case, what would be the research directions of the academia which a small scale should deal with?
Yeah. Who wants to answer this question first? From academia or from industry? I think it depends on maybe the kind of dependency. Jason, do you have any opinion about that? Who can assess the large language model?
Hello?
I know that it's a personal opinion. I don't understand it.
Yeah, I'd say if you want to be at the cutting edge, it definitely requires a lot of compute. Maybe I have like a bit of a not mainstream opinion, but I think we still don't understand a lot of very fundamental questions about how language models work. And I think even if you just have access to an API, you can create experiments that target like very simple but important questions. And I think it's still possible to do good research. Maybe it's harder, or you need some money to do API calls or to inference open source models. But I think there's still a lot that can be done just with simple experiments that try to understand, like, okay, if I change this part of the few-shot prompt, or if I ask the language model in this way, how does the behavior change? And what's the effect of using different models in terms of like different model families or the scaling behavior of models?
Yeah, good point. And then the comments. Okay, continue.
Okay, so industry first. No, I think this is not only for academic, because within the company, you also have their limited resources. So we have to really be very careful about how we invest in different type of things. But I agree what Jason said about actually each one of us can pay $20. You can experience yourself in terms of the experiments. Actually, what Jason said about like there's so many things you can try on the language model, and then you can identify something actually interesting, like what I presented about compressions. You can do that. You can go home and try it, like whatever story you want, and then that is a good question to answer. There's a kind of interesting large language model language, right? Is there? What is that, right? It could be itself, like this is something that no large language model can answer, right? And something like the state of mind, right? The theory, right? And you design some test to evaluate the models. And I think there are a lot of work there in terms of like not only assessing the capability of their model, but personally I believe that whenever you find a deficiency in a language model, you can first prove that in some data, but then you can also think about, maybe I missed something, right? Can I recast my questions? Would that actually guide it? Because the language model has their own language somehow. Could I recast in some way to presumably actually talk to language model in their way they understand? And then maybe I can elicit those kind of capability out. So we don't know, because we really don't know about, if you don't try, you never know the limit of the model yet, right? And then, so I would like to also pay attention to other evaluation paper now coming out from different places, like evaluating the GPT-V, like the vision type of things, and then for the new model. And then also, whenever you heard some new finding, research paper, I also encourage you to try it out on the GPT-4 or on whatever engine you can have. And especially, I want to emphasize, you can compare 3.5 and 4. And also the model keep improving. So you should try by yourself to see the differences and to appreciate the model, what they can do and what they cannot. You can personally verify all the claim, all the papers, right? Some say, oh, you cannot answer this question, but you can type in yourself to verify it. So that's a very important step in terms of like what opportunity there you can do research. I think there are plenty of opportunity. Myself, I feel, although a lot of people in the research in the academic think, oh, there's no more NLP researchers, but I see there's tremendous opportunity, because the reason I want to do summarization, because once you've done summarization, you can, on top of summarization, you can do something else, right? And now it's done in some way, but then you can think about how can I apply this to other things, right? So I'm still very optimistic about the things we can do.
Yeah, I think I would totally agree with everything Jason and Chinyu said. Like, I think there's like lots of opportunities at like every different level. Like, you don't need like huge compute to do interesting research, right? Like, you just need to think a little bit creatively. Like, of course, I think, yeah, you can't compete with like Google or OpenAI and train a bigger model than them, but that's like only one very kind of narrow type of research, right? So I think there's like lots of other things to do. And yeah, I think you can do this using the APIs with a relatively small amount of money, or like even, you know, if you don't have access to GPUs, just there's interesting things I think you can do with like Google Colab if you just pay, you know, $10 a month or something like that, right? So I would say, yeah, don't get discouraged just because you don't have, you know, these sort of very expensive GPUs you have access to, right? And I think it's important too for people in academia to be doing research on this, right? Because there's lots of important societal issues associated with large language models, right? So it's like, if only these companies are the people doing research on it, like I think that's, you know, issues about like privacy and security and sort of bias and things like that, I think is something important to happen, you know, in academia, not only done by companies, you know.
Yeah, my personal opinion is like the only barrier is like it's more on the hardware side, is like, can you have a 8 GPU server that allow you to train about like a 13 billion parameter models? If such GPU can be made available by NVIDIA, that would be kind of opened up a lot of research opportunities, I would say. But I think even, well, I think the Jason and Qingyu, and they can correct me, I feel like even in large companies, the person who can make decisions on training models that to the size we are seeing today is very few. So even give you 5,000 GPU, do you have a great idea that you will make anything greatly good? I think people who have good answer to that question is very, very few. So the question is, in academia, is it really limited by your GPU? Is like really limited by the creativity of or skills, right? So I think it's easy to blame onto we don't have enough GPUs, but I think it's way beyond something besides GPU that limit that what research we can do and we do well, right? So I think that's probably the antidote. I guess I'm like the optimistics. Like, I think I'm generally like the optimistics that a lot of work can be done with smaller models, but I do feel like I wish my dream list would be like a GPU that a GPU can train a 13 billion model from scratch. That's enough to plot the scaling law and kind of to study whether anything you invented that can be scaled up still cannot generalizable possibly. Because training like the model is, well, Jason will tell you more, it's not only the compute, the cleaning up the data and everything that's need like dozens of people of a team of that side, I think. Yeah, I don't know what Jason can tell us or Qingyu can tell us.
Do you have any comments
I
about that?
want to share a bit of my thoughts on this, because I think this is really a question about what is a good research project. So like, what is a good research paper? So like, I think a good research paper is the one that really change people's mind on something, like change people's view on something. So those kind of things. So for example, why we think GPT-2, GPT-3 is a great paper is because like originally we thought like language models are just language models, but when people scale that up, it actually got a lot more inside it, like emergent abilities that we never thought about. So this is a really good paper work contribution. So, but like, you know, to make this kind of like view shaping good work, you don't really need a huge computation resource to do that. For GPT-2, GPT-3, of course, but like there are ideas like transformers and many inferential ideas like chain of thoughts, right? You don't really need a huge amount of computation to do that. So that's the thing that I want to add there. And also, like, I want to share like something that my advisor Chris Dyer shared with me. So he he told me that he has this famous sentence. It's like slower models gets faster, but stupid models stay stupid. Okay, I want to add one thing to that. Is like I feel like expensive models gets cheaper. Slower models gets faster, but stupid models stay stupid. So don't work on stupid models. That's the case. Okay.
Yeah, I also want to add something here. Like, so actually, if I share like my personal story, I mean, first of all, I agree with all others. And I was preparing for a grant proposal with some ideas, and then ChatGPT appeared. And then I found out that ChatGPT does things way better than like anything, any models before. And even like when I imagine how my method would work, ChatGPT would do it better. So, and it was actually true. So I tried the ChatGPT and it just solved the problem. So I had to like change the direction of my grant proposal. And I feel like maybe this is like some opportunities could come from like some more fundamental like questions about language and also humans. So, and also we can imagine many applications like, and when we apply all these like even or like GPT-3, GPT-4 to apply to in the real world problems, we always encounter some unexpected like challenges. So this would be like a great opportunity for like those application problems.
Thank you. Yeah, thank you for your answers, and then thank you for your question. Yeah, it's because of time limitations. So actually, I didn't prepare any questions. Yeah, but so you know, we are LLM people, so that's the reason I use ChatGPT 4. Actually, someone suggest that one. Then, I mean, they suggest 10 questions. But yeah, I mean, I don't want to say more things. But the last one is quite interesting, and then I think it's kind of good. Yeah, the questions for wrapping up this panel discussion. Since actually also the head also mentioned about her personal experience, right? So then the answer, I just read these questions. Personal experience in NLP research. Can you share a personal experience or a project in NLP that you found particularly rewarding or challenging? Yeah. So I mean, you know, so there's audience, and then there are also the students, and then the NLP researchers who will just start recently, and especially the LLM, it appears recently. And you know, the ChatGPT was released November last year, so only it takes 1 year. So that it means that many people are trying to use LLM and then do the research. As you had said, it's kind of the new things are happening, and everything's a change. So from your personal experiences, so please share your minds and then the experience to the researchers who started the LLM research. So who wants to speak first?
Yeah, I guess I can say something about that. So yeah, I had recently, I think Wei was also part of this. So we had an experience recently very similar to Heiju's experience when ChatGPT came out. So we were working on a paper to submit to ACL, and ChatGPT came out, I think it was like 2 or 3 weeks before the ACL deadline, and worked amazingly well for our task that we're writing a paper about. And so we sort of, we got very stressed out at first, you know, but then we sort of were like, okay, maybe we can sort of add an experiment with ChatGPT to the end of the paper. So we sort of quickly put something together, and, you know, fortunately the reviewers were happy with it, and the paper got accepted, you know. So I think, yeah, it's kind of a, interesting time that all these models keep coming out and there's so many advances, and you might be sort of working on something and things change very quickly, right? But I would say, just don't get discouraged, try to just kind of, pivot a little bit and sort of include some additional experiments to kind of address this sort of thing, and usually it can work out, but I don't know.
Yeah, just to share one more thing. So I actually have one grant proposal written, the submitting deadline is before ChatGPT. And the review happened after ChatGPT. And all the reviewers asking how this thing work with large language like ChatGPT. And when we were submitted, it's not available. That's not existing. So yes, but I think ended up we just have to made a significant changes to the proposal we already written, right? It's completely a new proposal, but I do think that pointing to much more exciting directions that all my collaborators was we were getting this very early opportunity to think very hard what we can do with the kind of given the context of large language model. So I actually think that will make our work a lot better and more timely than if my original funding proposal gets funded and then we're kind of committed to work on this older kind of stuff. So I found the experience very rewarding. Actually, just to share with you that I can't tell funny is if you submit a proposal before it.
Yeah, so I want to share my personal experience. I mean, not the frustration, but kind of optimistic in a way. Because at my age, at my career age, I typically will have make a comparison. I'm going to play golf, but then it seems I cannot. My skill is not so good. So I have my golf assistant hit the ball for me. I said, oh, go there, right? That's like research assistant for me. I'm going to do something, and I'm not doing myself, but I'm a proxy of the graduate student doing for me. But what happened recently is this, right? So even for writing a code, right? I know Python, I know how to write it, but I seldomly write a code myself, right? And then but now I can actually just use GPT and say, this is what I'm going to do, and then you wrote a code for me. And to me, I think I'm kind of handicapped, get a new life, I can do it as I want it, instead of waiting for Jason to say, hey, Jason, can you come help me do this? No, I mean, he's great, right? He can do it maybe in 5 minutes. I have to figure it out, check online about the Reddit and whatever you have. But I find out that I can do that. And actually, my personal experience recently, there's a company, inside my company has hackathon. Actually, I do it all the hackathon myself, right? And then actually get a reward and a word of that result. I was so kind of refreshing to me. I think, oh, that's a great thing to happen to me at this age in terms of what you can do with the model. So I also encourage every one of you, to, besides your skepticism about the technology and then frustration, maybe writing proposal, and also seeing the good side about now you can writing proposal faster, right? All right, okay, and then so always think about the positive side about the technology you can use and use it to your own advantages. And also identify the deficiencies that then you can actually make a recommendation or suggestion of research proposals. Right, so that's my ending of this panel. Yeah, thank you.
Thanks. So, Youngjin, you want to do that?
Yeah, I would like to add my experience. My team has been working on large-scale training and scaling efforts, and with thousands of GPUs. And as you know, after ChatGPT came out, we couldn't do that anymore. All the GPUs are taken, and we got very big frustrations in the team. And but some change point was our intern came to the team, and he has very fresh view, and he didn't have that kind of barrier. He started from scratch whatever he has. Even we couldn't give any NVIDIA GPUs, so we just gave AMD GPUs. This is what you can use, and he was very happy. He didn't have that at school, and he just found a new way to utilize open source models and like make new research directions. And yeah, after that the whole team was very encouraged. And then we looked around, and people are doing various researches. Like, just we are now focusing on the different area, like in context running, and instead of looking at full stage of the training, we can like focus more on the post-training stage. And yeah, after changing mind, things are going quite well. So I would say we need to change the mind and break our barrier. And everything has changed since this new capability of ChatGPT and LLM. So I think there are lots of opportunities to explore. We don't know how disentangle this knowledge and language capability inside the language models. These kind of fundamental questions can be explored with the black box models and then smaller models. So I think for me, it was really important to break my personal boundary and the previous thoughts. Yeah, thank you.
Yeah, thanks. Yeah, Hyunwoo, you want to do that? Yeah.
Personally, when ChatGPT came out, I felt two feelings. First, looks like dialogue is dead. And second, since LLMs are now becoming more and more human-like, this is the perfect opportunity for students who come from psychology backgrounds, because you can now finally apply psychology-related tests or methods to LLMs to whether evaluate it or to make it even better. So I think in the era of LLMs, now we have the opportunity to have more interdisciplinary studies. Now we're finally entering the age of AI, I guess, what we really call AI. So I think there is a whole new field waiting for you and for us, and I think it'll be a very interesting future to live. Thank you.
Thanks. Yeah.
I have a small disagreement. I don't think dialogue is dead. So actually, I don't work on dialogue so much before until very recently. I think it's because of large language models made the baseline a lot of better kind of equal baseline that everyone have. So I start to be more interested in the opportunities opened up in terms of harder problems for dialogue side. Like how to ground onto physical world, or how to ground on kind of a longer document. I think before the chatbot is much more like a chit chat. So I think with the large language model is actually potentially do the real application that actually useful other than just simple chit chat. So I don't work on this before, but I started doing it last year. So I actually have the, I guess I'm very, very optimistic. I'm leaning on that, toward that extreme.
One thing to clarify, what I meant by dialogue is dead is traditional dialogue tasks are dead. Like usually we were mingling with these tiny little chit-chat data sets called persona chat and empathetic dialogues, but it's very small and you don't really get good models when you train on them, right? So that's what I said. That's what I meant when I said dialogue is dead. But now we have whole new data sets, such as Soda from our lab, and other chit-chat related tasks, or even negotiations. I mean, the one thing that I mentioned earlier about probability calibration is based on negotiation forecasting. Like you want to know what will be the outcome after this communication. So a whole new era of dialogue is waiting.
Okay, yeah, so because of time, so I wanted to listen to one panelist, the experience or the mind. No one? Yeah, Alan, you want to do that?
I guess I can add, maybe a little bit more on the dialogue thing. So I just would also like to chime in and say, I think it's a really exciting time for dialogue research. So I've been sort of working on this since like 2011 when we kind of first started using statistical machine translation before even neural machine translation to build these chatbots, right? And then, the early neural MT models, they would just say, I don't know, in response to everything, right? So we did all this sort of work with sort of like, reinforcement learning and adversarial learning to try to get them to say something more than just I don't know. But it turns out that I think scale was really the thing to get this to work, and now these models are kind of amazingly good. I don't know why, Siri or Alexa or, these, I guess Samsung has this, Bixby chatbot, why they aren't using these large language models, and you can't just sort of talk to your phone to kind of do all of these things. But I think that's something that we're going to probably see changing soon, where there's going to be much better dialogue systems. And I think it's an exciting area to work on.
Yeah, I also think dialogue data that are actually widely available, but most of because of privacy issues, so you don't have access to as a researcher. But for companies, they do, right? And also even I think Alan's first work on this statistical models applied to dialogue is using the Twitter response, Twitter reply, right? So that is public data you can get. Those are already in millions or even billions if you actually have the hardware to train. I think there are a lot of data potentially available. I think that's why I didn't work on dialogue before. Is for example, the Blender bot from Facebook, right? Or they can collect a lot of more data than you can as an academic in the academic setting. So they can train this type of models. But now because of the pre-trained language model available, so you actually had a very good starting point. So you don't cannot build this dialogue model from scratch, but you can have actually a very good starting point to actually invest much more interesting questions, much more realistic questions than before without accessing to all this private data. So actually, I think it's an exciting time for dialogue.
Yeah, right. So anyway, so thank you for the responses for the question from the GPT. And then, so because of time, so I need to wrap up today's the panel discussion. Actually, so the title of this program is Optimism, Pessimism, and the Realism of Large Language Models. And I believe that there are so many optimistic point of view. But I also wanted to ask about the pessimistic part, but because of time limitations, I needed to wrap up today's discussion and the program. So let's thank speakers, and then thanks to participating in these discussions. Thank you very much.